Right, okay, students, can you all hear me? Can you hear me, students? Right, okay. Right. So, good evening for all of you, and today we are going to discuss Memory Booster paper number 4 and Memory Booster paper number 5. So both, first of all, let's discuss a fourth paper, right? So there are 15 MCQs to discuss. So let's go one by one. I hope that all of you tried these questions. Before the discussion, definitely you have to try these questions. Understood? Question number 1. The ratio between the speeds of oxygen molecule and helium atom with the same de Broglie wavelength is, right? So they're asking about the de Broglie wavelength, the ratio between the speeds of oxygen molecule and helium atom. Students, we know that de Broglie's equation is lambda equal h over mv, right? This is the equation. So they have given for the oxygen and helium, right? For the oxygen and helium. So when we consider the lambda wavelength, so that is same. Lambda is same for oxygen and helium, same value. What about the mass? Let's consider the volume. Speed is VO2 and V helium, speed values. And what about the masses? We can take the relative atomic masses and the relative molecular masses. So they have given relative atomic mass of helium is 4. Relative molecular mass, relative atomic mass of oxygen is given 16, but this is oxygen molecule. Therefore, let me consider that one as 32. Right? So here I'm considering the relative molecular mass or relative atomic mass. AR, OMR. In chemical calculations, we are learning about these things. In O-level time also, you have learned these things. You have an idea about this one. Okay? Since they have given that same lambda, same wavelength, we can say that Planck's constant is a constant value. So we can say that M1 V1 equal M2 V2, right? Can you understand how did I take that one? Now students, we know that lambda H over MV. Let me shift this MV term and I'll take lambda here. This is a constant. H is Planck's constant. What does mean by lambda? Lambda is de Broglie's wavelength. For the oxygen molecules and helium gas, for both the gases, lambda is same. Therefore, this is not changing. If it is not changing, I can take this one as a constant. Then MV product is a constant. Then I can say M1 V1 equal M2 V2, right? That means for the oxygen gas, M1 V1 product, MV product for the oxygen gas is equal to the MV product for the helium. Then here I can take that. They're asking about the ratio between the speeds, no? Ratio between the speeds, V1. Let me consider V1 is the speed of oxygen, MO2, and this is VO2. This is M helium, and this is V helium. So VO2 over V helium, this is equal to M helium over MO2, right? The speed ratio. So what is the mass I have taken here? 4, and this is 32. Then I can say here 1 and here 8. So 1 over 8. So 1 over 8 means we can take that one is 0.125. So when you divide 1 by 8, answer is 0.125. Question number 1, answer should be second one. Raise your hand those who obtain the answer as the second one. 1 Raise your hand those who obtain the answer as the second one. Raise your hand those who got the answer as second one. Okay, very good. If you have any doubts, let me know, right? Question number one, answer is second one. It's very easy. They have given that lambda wavelength. De Broglie's wavelength equation is lambda equal h of mv. So lambda is same, and the velocities are different, and the masses are different. So therefore, mass velocity product equal to mass velocity product of the other one, because according to the equation, I can shift mv product here, and lambda can be taken here. Then h over lambda is a constant value. That means mv product is a constant. m1 v1 equals to m2 v2. So that's how I meant for the answers, right? Question number two. Question number two is also a calculation. Let's see. A bulb emits light of lambda 4500 angstrom. The bulb is rated as 150 watts, and 8.7% of the energy given is converted into light, right? So 8.7% of the energy given is converted to light. How many photons emitted by the bulb per second? How do you find out this one? They have given the bulb emits light of, right, light of 4500 angstrom. The bulb is rated as 150 watts. We know that 150 watts means that is what exactly? Power, joules per second. We know that power equals to energy over time, right? So the unit for the energy, we can take that one as joules. Time is seconds, and this is actually considered as watt. So joules per second is considered as watt, right? So this is the energy per second. So they have given the bulb is rated as 150 watts. So 8.7% of the energy is given, converted into light. How many photons are emitted by the bulb per second? Right, students, how do you find out that one? First of all, let me calculate the total energy that is converted into light per second. Look at this one. According to the what value they have given, I can find out the energy converted to light. Total energy converted to light. Converted to light. So they have given 150, no? 150 joules per second. But remember, they have given percentage value 8.7. Cancel off. So without simplifying, let me keep this one as 1.5 into 8.7 joules per second. So this is the total energy per second, right? The total energy converted to light per second, per second. Now they have given the wavelength of the light, 4500 angstroms. Students, we know that lambda is equal to 4500 angstroms. We can write down this one in meters. Angstrom is 10 to the power minus 10 meters. In theories, we learn this one. So therefore, 4.5 10 to the power minus 7 meters. This is the lambda, the wavelength. Okay, wavelength. Then we can find out the energy of a photon, right? Energy of a photon. How we can find out energy of a photon? So we know the equation E equal hc over lambda. The equation that we learn E equal hc over lambda is used to calculate the energy of a photon. Therefore, hc over lambda, Planck's constant 6.626 10 to the power minus 34 joule seconds, right? And what is the velocity of light? 3 into 10 to the power 8 meters per second, divided by lambda wavelength is 4.5 10 to the power minus 7 meters. Let me simplify the units. Meters will cancel off, second per second will cancel off. And here we have 6.626 multiplied by 3 divided by 4.5 and 3 cancelling off. No? 1 here. Both are divisible by 3. So therefore this is 1.5. So 10 to the power values. 10 to the power minus 7 will go for the numerator as plus 7. Then 10 to the power 15. 10 to the power minus 19 joules. So this is the energy of a photon. And this is the total energy. Then can't you find out the number of photons emitted per second? Can't you find out this? Students, you have to divide the total energy by energy of a photon. Then you will obtain the number of photons. In order to obtain the number of photons per second, you can divide the total energy per second by the energy of a photon. 1.5 into 8.7 joules per second, it is divided by 6.626, 1.5 10 to the power minus 19 joules. Understood? Joules will cancel off. Then we have the answer like, what is it? 1.5 into 1.5, 8.7 divided by 6.626, 10 to the power plus 19. These are the number of photons per second. They're asking per second. So when you simplify this one, what should be the answer? So all of the values are 8, 2.8, 2.95, 1.98, right? So what is the answer that you obtain after simplifying this one? Answers? No one got the answer. Put your answer in the chat box. Binudi, okay, let's see whether your answer is correct or wrong. Right? Shall I do the simplification? Students, I can take that 1.5 multiplied by 1.5 is 2.25. 15 squared is 225, so therefore 2.25. So here we have 8.7 and here we have 6.626. So check the log. Take the log table and do the calculations. 22.5 is 3522 and 870 9395. 9395. Take the summation 7 11 here, 8 9. Okay. Yes. What is the log value for 6626? 6626 8213, no? Take the difference. 4074 4704 4704 295 3 2953. Yeah, approximately we can take that 29.5 neither. Yes. Let me write down the correct value. 2953, 2.953 10 to the power 19 per second. So what are the answers they have given? 2.80, 2.95, 1.98, 2.98, 2.8. Approximate answer is 2.95 into 10 to the power 19 per second. So these are the number of photons per second. So that's a good calculation, right? Raise your hand those who obtain the answer in this way. 2.95 10 to the power 19 per second. Raise your hand again. I want to see. Please raise your hand. Sehara, Vinudi, Akira, Shabnam, Vishma. Very good. Very good. Huh? And Andrew. Okay. Good. Anjali, okay. Good. Very good. Okay. Students, remember these questions are extracted from school term test papers. Huh? You don't think that we won't get these kind of calculations in the exam, right? So question number 2, answer the second one again. Question number 3 is related to the hydrogen emission spectrum. First of all, complete this one. Quickly complete this one. If you have any doubts, put your doubts in the chat box. In this calculation, they have given the power of the bulb. The energy emitted by the bulb is actually 150 joules per second. 8.7% is converted into light. Then I can find out the energy of the light per second. It is 1.5 into 8.7 joules per second. Then they have given the wavelength of that light 4,500 angstroms. So therefore, about 4.5 10 to minus 7 meters. Using that one, we can find out the energy of a photon. And this is the total energy emitted per second. So when you divide the total energy by energy of a photon, you can obtain the number of photons. It's very simple idea. We have discussed this idea in the exercise questions also, right? No, we don't have to memorize these masses of the atoms. And remember, those are not the masses, they are the relative masses, relative atomic masses and the relative molecular masses. You have used them in all our time also. It's not a big deal. So we know that helium is 4, oxygen is 16. So you have done calculations in your all over time also. So instead of the mass, I have taken their relative mass. Okay. And you don't have to remember that one, but automatically when you're doing so many calculations, you will remember these things. Okay. You don't have to put any effort for that one. We have discussed about the angstroms in the theory class. Okay. It's not fair asking these kind of questions. Right, okay. Are we done? Shall we move to the next one? Question number 3. Right, okay. Are we done? Shall we move to the next one? Question number 3. Which of the following statements are not true regarding the hydrogen emission spectrum? Not true, okay? That means they're asking about the false statement. Students, can you remember the hydrogen emission spectrum that we discussed? So let's move to the hydrogen emission spectrum. Here I'm going to consider the energy level diagram. Okay. In the last few weeks, we discussed about the hydrogen emission spectrum, in this way. N equal 1, N equal 2, N equals to 3, 4, 5, and 6. We know that Lyman series is obtained in this way. So this is the Lyman series. Lyman series belong to which region in the electromagnetic spectrum? Can you remember? Lyman belongs to which region? Ultraviolet, UV. Okay. Then here we have Balmer series. I told you that Balmer series is actually partly visible light region, no? N equal 3 to 2. First of all, let me consider 6 to 2. Which is purple color, violet color. 5 to 2 in this way. 4 to 2. Then this is 8 to 2. So these 4 colors are observable because they belong to the visible light region. H alpha, H beta, H gamma, and H delta. I told you that, students, in hydrogen emission spectrum, the next series, what is it? After Lyman, Balmer series. Balmer series belong to the visible light region part. So therefore, I can say that Balmer partly visible light region. Partly visible light region. So after that, we know that Paschen is obtained. All the electron transition is towards the third principal energy level. Then bracket after that one. Lyman, Balmer, Paschen, bracket fun. Paschen, bracket fun, those series actually belong to the IR region in the electromagnetic spectrum. Okay. So therefore, this is the hydrogen emission spectrum that we discuss. Accordingly, we can draw the spectral line diagram also. Now go for the questions. They have given transition from N equal 4 to N equal 2 correspond to the H beta. N equal 4 to N equal 2. That statement is correct, no? H beta, green color one. Statement number A is correct. The energy difference between N equal alpha and N equal 1 is the, sorry, students, it should be N equal infinity, okay? The energy difference between N equal infinity and N equal 1 is the first ionization energy. Is that correct? Remember, first ionization energy means we know that the electron is removing from the first principal energy level. Hydrogen is having only one electron. We are removing that electron from the first principal energy level. Then that electron is going for which energy level? We can't predict it. We have to assume that it is going for the infinity level. So therefore, as they have given second statement, energy difference between N equal infinity and N equal 1 is the first ionization energy. That's true. B is correct. Simple C. Each line in the spectrum corresponding to the energy level of in hydrogen atom. Can you remember? In the theory class, I told you, in the tutorial, there is a statement I gave you. Each spectral line is representing the energy gap between the energy levels. They are not the energy levels. This is the way that they are giving the statements in the exam. They are always trying to confuse us. Questions are very tricky. Understood? Remember, students, each spectral line is representing energy gap between the energy levels, not an energy level. Okay. So therefore, C statement is wrong. D. Energy gap between N equal 2 and N equal 1, that means this gap, equal to N equal 3 and N equal 2. It's not correct, no. As you can see here, 1 to 2 gap is greater. even consider the least energy gap between Lyman series, that least gap is also greater than the highest gap in the Balmer series. So therefore, we always consider that here Lyman series has the highest frequency and the highest energy. Can you remember we learned that for this direction, energy and the frequency increasing. And what will happen to the lambda wavelength? Lambda wavelength is decreasing for that direction, right? So n equal 1 to 2 gap and n equal 3 to 2 gap, that is not equal. So therefore D statement is wrong. C and D both are wrong. Therefore, students, we have to consider answer for question number 3 is third one. Raise your hand those who choose the answer as third one. Raise your hand those who got the answer as third one. Okay, good. There are some students. Yes. Remember, okay, I forgot to tell you that one. Actually, students, please keep a MCQ review book for this one. Okay. We are going to continue this memory booster paper discussion till the exam. Don't worry. So therefore, please keep separate book for this one. Okay. Understood. Now, from the July onwards, I told you that we are starting our official paper class. So therefore, I'm taking this time for our paper class. Then memory booster paper discussion will be conducted in another day. I will inform that one later. Before every class, you will have this kind of a paper. So please do that paper. If I couldn't do that discussion, definitely I'm going to send you a review, a printed review for the physical students. And for you, I will upload a PDF. Okay. So if it is compulsory to discuss that one, definitely I'm going to discuss. Okay. First few papers, definitely I'm going to discuss. Okay. Nothing to worry. Remember, doing MCQ should be a habit. ඔයගොල්ලෝ එදිනදා කරන දේවල් තියෙනවානේ. ඒ වගේ හැබිට් එකක් වෙන්න ඕනේ MCQ කරන එක. MCQ කරන එක හැමදාම නිකන් පුරුද්දක් කරගන්න. Then it's very easy. Right? So, remember students, in the chemistry exam paper, the easiest part is MCQ. If you can score more than 45, 46 MCQ, then getting A is nothing. Essay is little bit hard compared to MCQ. So therefore, focus on MCQs much. Do MCQs every day. For other subjects also, you can follow this one. For physics and biology, do MCQs daily, right? Just practice 10 MCQs daily. Then you can count how many MCQs you have tried. For a week, you have tried. Now, just imagine you are doing 10 MCQs per day from one subject. Then per week, how much you are doing? 70 MCQs. Per month, how you are doing? Minimum, you are doing 280 MCQs per month. Can you understand? Then 10 months means, right? 10 months means 2,800 MCQs that you have done. Just imagine you are skipping some days. For an year, you have done 2,800. That's a big deal. That's a big thing. Okay. And one more thing, it's not about the quantity. You have to learn from them. Right? When you see MCQ, answer should come automatically within few seconds. That much you have to practice. Okay. So question number 3 should be like this. Raise your hand those who understood the third one. Raise your hand those who understood the third question. Do you have any doubts there? No, Vinodi, in the simple B statement, that's a typing error. It is not alpha, it should be infinity. Because we don't have n equal alpha like energy level. We have 1, 2, 3, 4 likewise energy level. It should be infinity, okay? That's a typing error. So that's why I asked you to correct that one as infinity, okay? Second point, some of the students are asking to explain the second point again. Energy difference between n equal infinity and n equal 1 is the first ionization energy. Remember students, first ionization energy means again, we are removing electron. right? In the last class, we discussed about the first ionization energy, right? Ionization energy. We are removing electron from the valence shell. Now, in hydrogen atom, we know that only one electron is there. So we are removing that electron. Then just think about after removing that electron should be where exactly? We can't predict that one. So we are assuming that electron went for the infinity energy level. Since we cannot predict that one, we don't know whether it is in the 7th one or 10th one or 25th one or we don't know. We are assuming that electron went to the infinity energy level. That's how the ionization energy is defined. That electron is going for the infinity energy level. So therefore, ionization energy means the energy difference between n equal 1 to n equal infinity, right? That means we are removing that electron from the first principal energy level and we are going to keep that electron in the infinity energy level. Then that gap is the ionization energy. Understood? Right. Now let's move to the question number 4. Which of the following statement is true regarding alpha, beta, gamma radiations? Gamma rays deflect towards the negative electron in an electric field. What do you think? Gamma rays? Is there any possibility? Do gamma rays have a charge? No. Simple A statement is wrong. Alpha rays are not deflected in a magnetic field. Students, alpha rays are deflecting in a magnetic field, perpendicular direction. Electrons, positively charged particles, all the charged particles are deflected perpendicular to the magnetic field. And remember, if electrons are moving for a direction where perpendicular to the magnetic field, then positively charged particles are going for the other direction. That means it is behaving as in the electric field. In the electric field, we know that electrons are moving towards the positivity and the positively charged particles are going for the negativity. So likewise, here in the presence of a magnetic field, anyhow, whatever the charged particle, they are moving perpendicular direction towards the magnetic field. So that perpendicular direction can be opposite for the negatively charged particles and the positively charged particles, right? That means just imagine this is the magnetic field, right, for this direction. Then students, we can say that alpha particles are coming here. Alpha particles are moving for this direction, upward. Then electrons, negatively charged particles, they are going for downward. Can you understand? Anyhow, those charged particles are perpendicular to the direction of the magnetic field. Okay. So therefore, simple B statement is also wrong. In question number 4, simple A is wrong. Simple B is also wrong. Simple C. E over M ratio of beta rays are higher compared to that of alpha rays. Right? Okay, let's take. We have beta rays and we have alpha. E over M ratio for the beta. What is it? Students, beta means actually electron. Charge is what? 1.602 10 to the power minus 19 coulomb. What is the mass? So this is the mass of electron. So therefore, let me write down that is Me. What is that for the alpha particles? Alpha means helium nucleus. Helium nucleus means what? Helium 242 plus. 2 electrons are removed. Okay, 2 electrons are removed. So therefore, charge is plus 2. That means it carries a charge where twice the 1.602 10 to the power minus 19 coulomb. Am I right? Students, there are 2 protons excess because 2 electrons are removed. Now in that atom, in that cation, in alpha particle, we have 2 protons only. Charge of 1 proton is 1.602 10 to the power minus 19 coulomb. Then there are 2 protons, therefore 2 into. What is the mass? What do you think about the mass? Students, mass is actually, there are 2 protons and there are 2 protons and there are 2 neutrons. So therefore, we can consider 2mp and 2mn in this way. So I can say that, so 2 is a common factor, I can cancel off it. Then 1.602 10 to the power minus 19 coulomb divided by mass of a proton plus mass of a neutron. So this is the E over M ratio for the alpha particle. Now, just imagine we have two fractions, 3 over 5, 3 over 8. Simple maths. Numerator is same, but the denominator is different. Okay. So denominator is large in 3 over 8. Denominator is lower in 3 over 5. Which fraction is large? Which fraction is larger? Which fraction is larger here? 3 over 5 or 3 over 8? Yes, we can say that 3 over 5 is larger. Remember, students, when the denominator is lower, that fractional value is greater. When the denominator is larger, that fractional value is lower. Now, for the beta particle, we have 1.602 10 to the power minus 19 divided by the mass of electron. Mass of electron is negligible compared to the mass of proton and neutron. Right, 9.107 10 to the power minus 31 kilogram. Right, and here numerator is same, 1.602 10 to the power minus 19 coulomb. Mass of a proton and mass of a neutron. Then we have both together. Then here denominator is larger. When the denominator is larger, what will happen to the E over M ratio? It is lower. Here denominator is lower, therefore E over M ratio is larger. Right? Then students, I can say that E over M ratio for the beta particles is greater than E over M ratio for the alpha particles. Can you understand? Can you understand what I have explained here now? Raise your hand those who understood that one. It's a simple logic. E over M ratio for the beta particles are greater than E over M ratio for the alpha particles, because in the denominator of the beta particles, E over M ratio, we have only the mass of electron. But for the alpha particles, we have neutrons and protons. Actually, you don't have to write down these things. In your mind, you can do this one. Because you know what does mean by electron, beta particle, and you know what does mean by alpha particle. Alpha particles means helium nucleus. Then you can understand that there are two charges and there are two protons, two neutrons. So denominator is larger. Since the denominator is larger, we can say that fractional value is lower. Logical. Understood? Don't worry, since this is the beginning, you will practice these questions harder. Then you will automatically will be able to do these questions. Okay. Now write down everything. It's okay, fine. So therefore, E over M ratio of beta rays are higher compared to that alpha particles. That's true. C statement is true. D statement. The deflection angle of beta rays within a magnetic field is larger than that of alpha radiations. Students, we have discussed this one. We have discussed this one not only in the magnetic field, even in the electric field. Remember, when the mass is lower, it can easily move. The deflection of the angle is larger. Can you remember in the alpha, beta, gamma particles, discovery of radioactive particles, we did an experiment, right? In that experiment, I told you that beta particles are having the lowest mass, but the angle of deflection is greater, right? In this way. Just imagine, here we have two charge plates like this. So this is positive and this is negative. Radiations are coming like this. So here gamma radiations are going in this way directly without any deflection. But beta particles are deviating like this. Alpha particles actually, deflection of angle is very low. These are alpha particles and these are beta particles. Because beta particles are lower in mass. Since the mass is lower, it can easily deflect. ළමයි මම ඔයගලන්ට කිව්වා බර අඩුයි නම් එයාට ලේසියෙන් දුවන්න පුළුවන්. හරි බර අඩුයි නම් එයාට move වෙන්න පුළුවන්. බර වැඩි නම් එයාට move වෙන්න බෑ. Right? That is the concept. Yes, that is correct. Simple D statement is also correct. C and D correct. So therefore answer is third one. So they have given only A, B, C, D statements. How did you take the answer as third one? Now you have to listen for this one again. Now I know that some of the students are not aware about this one. Now listen to this one very carefully, okay? In our A-level exam paper, we have 50 MCQs. Out of those 50 MCQs, MCQ number 31 to MCQ number 40. Students, they are giving 4 statements, A, B, C, D. Likewise, they are giving 4 statements, right? So I'm talking about the A-level exam paper, question number 31 to 40. Listen to this one very carefully, okay? Then, now we know that in the answer sheet, we have given options like 1, 2, 3, 4, 5. These are the options. Then why they have given A, B, C, D? So there is a particular process for that one to go for the answer. If statement number A and B are correct, if statement number A and B are correct, what is the option that we have to choose? Number 1. Okay, we have to choose answer number 1. If B and C statements are correct, we have to go for the answer number 2, option number 2. If the C and D statements are correct, then the answer is number 3. If A and D are correct, then we have to go for the answer number 4. Then they have given any other option. For any other option, what are the any other options? Only A correct, only B correct, only C correct, only D correct. If not, we can say A and C correct, B and D correct, A, B, C correct, B, C, D correct, all correct, all wrong. Can you understand? So there are so many options. For those options, we have to choose the answer number 5. Can you understand? I gave you a past paper question tutorial. In that past paper question tutorial, in the first page, I have given you instructions. In those instructions, I have given you this procedure. Question number 31 to 40, you will be given these kind of 4 statements. If A and B are correct, answer is number 1. If B and C correct, answer is number 2. If C and D correct, answer is number 3. A and D correct, therefore answer is number 4. Any other option, answer should be number 5. I'll tell you later how that question number 41 and 50 will come. Raise your hand, those who understood that process of doing question number 31 to 40 in A-level exam paper. Read the instructions I have given in the past paper tutorial again. Now, understood? Right. So for the question number 4, the reason I have chosen the answer as number 3 is C and D statements are correct now. So therefore, option is number 3. C and D correct, therefore option is number 3. Why there is this ineffective procedure, sir? I don't know exactly why they have given like that, but yes, there is a procedure. Maybe they are trying to make the paper more competitive. They are trying to increase the competition. Because while choosing these answers only, you are making mistakes. Right? Remember, students, A-level exam is a competition. It's a tough competition. Right? So not only the knowledge they are testing. No point of that one, but this is the way of the exam paper. What to do? They could have simply given 5 options and chose the answer number 1, right? See? I think in the bio paper also there is a procedure like this. I exactly don't know. I did combine that stuff. Ask from your biology teacher. Right, okay. Are we done? Question number 5. Which of the following are true? So in the combined maths tricks, Akif, in the combined maths paper, they are not giving MCQs. So they are giving structured essay questions. PO and applied, 2 papers are there. You know that one. In the part A, you know that there are 10 structured essay questions. Small questions are there. Each question is carrying, I think, 25 marks or something like that. So there are 10 questions, 250. From the essay papers, you can collect 750,000. So for the PO paper, 1000 marks. For the applied paper, 1000 marks, 2000. Then 2000 is rounding off of 100. Okay. So it seems that biology is easy again. 2000s. See, students, our A-level combined maths paper. Biology students, you should know that in A-level combined maths paper, they are giving 2000 marks for the PO paper and the applied paper. PO maths and applied maths. Okay. For the chemistry essay paper also, they are giving 1000 marks. Biology is hard, sir. Okay, right. So let's fight later. Which one is hard? Is the set score for bio higher, sir? Yes. Yes. Now for an example, in order to go for the now, what is the best university for engineering? Moratuva. What is the best university for medicine? Colombo. In order to enter for the Colombo University from Colombo district, you should get, I think, minimum 2.5, 2.6, 2.7. For Morato engineering, you can get, after getting 2.0, 2.1, you can enter for the Morato. Sometimes very rarely 1.9 also. Right? In our time, actually 1.9 also went for the Morato University. I think now it's a little bit higher, 2.0, 2.1 likewise. Medicine is not possible for the 2.1. Colombo medicine is not possible. 2.5, 2.6. So likewise, ranks only, set score values only will enter for the medicine. Okay. For the bio, actually, yeah, set score is higher. Okay. And when we consider bio and combined maths, fail rate in maths is low, very higher. Fail rate, right? Bio can easily pass. Anyone can pass. Normally, students are passing biology without any issue. But combined maths, there is an issue in our country. Combined maths passing rate is actually very low. Okay. Why is this? Why is like that? So okay. So let's discuss that one later. Okay. In the theory class, let's discuss. Now let's go for the question number 5. Which of the following are true? All elements contain more than one isotope. Students, is that correct? All elements contain more than one isotope. Is it correct? All elements contain more than one isotope. Remember, students, some of the elements are there in the periodic table. They do not have isotopes. For an example, fluorine doesn't have isotopes. Remember that. So therefore, all elements contain more than one isotope it's not correct. Okay. Simple B. Even though the atomic numbers of isotopes of the same element are the same, their mass numbers are different. Yeah, that's why isotopes are obtained. Isotope means same atomic number but different mass numbers, right? Simple B statement is correct. Question number 5. A is strong. B is correct. C. Isotopes of the same element are nucleides that are different from each other. Students, correct that one as isotopes of the same element are nucleides. Nucleides, okay? Isotopes of the same elements are the nucleides that are different from each other. Yes, that's also correct. Nucleides means, remember students, there are different number of nucleons. For an example, hydrogen 1 1, hydrogen 1 2, hydrogen 1 3. Nucleon number here is 1. Nucleon number here 2. Nucleon number here is 3. Nucleon number means number of protons and number of neutrons. So therefore, these are considered as specific number of nucleon numbers. So therefore, these are known as nucleides. These three isotopes are actually considered as three different nucleides. D. All isotopes of the same element have equal abundance. No, that is wrong. We cannot say that all the isotopes have the equal amount of abundancy and the stability. That's wrong. Only some amounts, some isotopes are having the relative abundance is stable, a higher value. Now, for an example, this is actually very high, 99%. Sorry, this is 99%. So this is actually even lesser than 1%. So therefore, relative abundancy cannot be said. D statement is wrong. B and C correct. Then what is the option? If B and C correct, second one. If B and C correct, answer is number 2. Raise your hand, those who choose the answer as number 2. Raise your hand, those who got the answer as number 2. Good. Question number 4, answer is third one. Question number 5, answer is second one. Question number 6. Incorrect statement regarding gold foil experiment related to the nuclear model of atom is R. This experiment was done by Geiger, Marsden, J.J. Thomson. Right? Students, tell me which one did the gold foil experiment? Rutherford. Ernest Rutherford with his two students, Hans Geiger Ernest Rutherford did the experiment with two students, Hans Geiger and Ernest Marsden. Okay. So therefore, simple A statement is wrong. Most of bombarded alpha particles penetrate through the gold foil without any reflection. That's correct. We learn it. Simple C. Positive charges of the atom is considered in a dense central core according to this experiment. Yeah, that's also correct. In this experiment, sodium metal can be used instead of gold. No, sodium atom cannot be used once. That's not possible. I told you why we are using gold-like element, right? So they should be some kind of inert, right? And they should be the alpha particles should easily penetrate through that one. So sodium atoms actually metals. So therefore, it's not possible to use sodium, right? So therefore, we have to use some other metals like B and C. Correct. Question number 2. What is the answer? Second one. Question number 6. Answer is second one. They're asking incorrect statements, no? Students, they're asking incorrect statements. Number 1, A and D statements are incorrect. So A and D means answer is number 4. Question number 6, answer is number 4. Be careful. Sometimes they're asking incorrect statements also. Question number 7. Which of the following ions have a charge of 3.204 10 to the power minus 19 coulomb? So students, this is actually the charge of 2 electrons, right? Because 1 electron is 1.602 10 to the power minus 19 coulomb. So this is actually twice that value. So let's see. Number 1, ammonium NH4 plus. So NH4 plus means there is a positive charge. So therefore I can say that one proton is in excess 1.602 10 to the power minus 19 coulomb. That is the charge. So therefore we can't consider that. P sodium plus. So this is also same as that. Only one proton, can't take. Magnesium 2 plus, yes. 2 protons are there. So that should be 2 times 1.602 10 to the power minus 19 coulomb. Then we are getting that value 3.204 10 to the power minus 19 coulomb, right? So therefore C is correct. What about sulfate? D. SO4 2 minus. Remember students, SO4 2 minus means 2 minus charges are there. So the electron charge 1.602 10 to the power minus 19 coulomb. So that is also 3.204 10 to the power minus 19 coulomb. C and D can be taken. Therefore, question number 7, answer is third one. Raise your hand those who got the answer 7, third one. Good. Right, okay. Now let's move to the question number 8. Consider the following statements relevant to an electron. Which statement is true about it? De Broglie showed that an electron behaves both as a particle as well as a wave. Students, in his equation lambda equal h over mv, both particle nature and wave nature is there. But de Broglie experimentally proved the wave nature of the electron. In the theories also, I told you that he has proven the wave nature of the electron, right? So here they have given de Broglie showed that an electron behaves both as particle as well as a wave. So what we can consider here? Dual nature, no? Yes. So let's consider simple A statement is correct, but there is a small issue that he theoretically proved that the wave nature of the electron, okay? But anyhow, using that de Broglie's equation lambda equal h over mv, we can show the particle nature and the wave nature both. So therefore, yes, simple A statement is correct. Question number 8. Question number 8, simple A statement is correct. Simple B, the energy present in electrons of atoms depend on the energy level in which they are present. Yes, that's what we learn under the Bose theory. I told you that in the Bose theory, energy levels, electrons are located in energy levels. These electrons are having those energies. When they are jumping to the energy levels, they are absorbing energies or releasing energies. So those energies are belong to what? Exactly, electrons. So therefore, that's true. Simple B statement is correct. Simple C. The energy that must be supplied to the electron present in the first S energy level of a hydrogen atom to take it out from the infinite number of energy levels is 1312 kilojoules per mole. This is its first ionization energy. Yeah, that's correct. I told you that first ionization energy means we don't know to which energy level that electron is moving. it can go for the infinity energy level, infinite number of energy levels. So that is known as first ionization energy. That's correct. Particle with a charge nature of atoms named as electrons by George Johnston Stoney. Particle with a charge nature of atoms named as electrons. What is the issue in the statement? It's correct that electrons are named by George Johnston Stoney. That's okay, fine. It's correct. But particle with a charge nature of atoms, is that the only particle in atoms charge nature with charge nature? Electron. Don't we have any other particles? We have protons also. So therefore, particle with a charged nature of atoms named as electrons by George Johnston Stoney, that statement is not completed. If they have given electrons are named by Johnston G. Stoney, yeah, right, that's correct. But here, particles with charged nature of atoms, particles of the charged nature of atoms means, students, protons are also there. Protons are named by, is that Johnston G. Stoney? No. So therefore, the D statement is not correct, right? You can argue with me, right? You can argue with me. I'm not accepting the D statement because of that charge nature of the atoms, particle with the charge nature of atoms, right? So ABC statements are correct. Then what is the answer? If A and B and C statements are correct, what is the option for this one? Yes, that should be number 5. Okay. Now, again, we have a nuclear reaction is there. Let's see. Right, okay. Let's move to the question number 9. Uranium 92, 238 plus X producing plutonium 94, 241. They are asking X should be. That's very easy. Students, let me consider here simple A and simple B. Okay. And then I have to find out A and B. So when we are balancing the nuclear reactions, we know that we have to take the summation of F side equal to the summation of right side in atomic numbers and the mass numbers. So 9 to 2 plus A summation is equal to 94 plus 0. So therefore A equal to. Then here we have 238 plus B. This is equal to 241 plus 1. That means 242. So therefore B should be 4. So A equal to B equal 4. That should be alpha particle, right? 2, 4. So alpha particle 2, 4. Question number 9. Answer is first one. That's very easy. Very simple. Raise your hand those who got the answer as the first one. Question number 9 is very easy.
Sandeep sir.
Ayman, if you have any doubts, put your doubts in the chat box. Don't speak to the microphone. If you have any doubts, put your doubts in the chat box. So in the 8th question, it doesn't mean that all the particle, right? It says that just a particle, so we can consider it electron too, right? Yes, that's also correct. Biology විභාගයේ ලකුණු කපනවනේ. ඒ කියන්නේ හරි වැරදින උත්තර වල ලකුණු කපනවද? Biology විභාගයේ. Right. I think that D statement is wrong, right? So particle with the charge nature of atoms means actually we have to consider, we can consider proton also. In that case, actually we can't consider that statement is correct. Understood? So let's move to the question number 10. Energy of a certain radiation is 4.5 10 to the power minus 19 joule. The wavelength of the radiation when the speed is equal to the speed of light. Energy is given. Okay, that's easy, no? Let's see our lambda. Lambda equal 6.626 10 to the power minus 34 joule seconds. Those who did the calculations, put your answers in the chat box. I want to see those who did the calculations. Before I complete the calculation, those who did the calculation, put your answers in the chat box. 4.5 10 to the power minus 19 joules. Joules will cancel off. Second per second will cancel off. Lambda equal 1.5. 6.626 divided by 1.5. 10 to the power minus 15 minus 7 meters. Okay. So when you divide this one by 15, 8213, 0.15 0 is 1761. 6452 anti-log. 4417. 4417. 10 to the power minus 7 meters. We can convert this one into nanometers, 441.7 nanometers. Approximately, yes, we can take that. Approximately answer is 441 nanometers. So therefore, question number 10 answer should be fourth one. Raise your hand those who got the answer as the fourth one. Raise your hand those who got the answer as 441 nanometers. Plus, that's a simple calculation, right? You can't make mistakes in this kind of calculation, okay? These are very simple calculations. Right. Question number 10 answer is third one, sorry. It should be third one. Raise your hand those who got the answer as third one. Again. Right. Okay, good. Very good. Question number 11. The evidences for existence of the electrons in atoms in energy levels can be obtained by particle irradiation experiment, by cathode ray test, by ionization energy data, by atomic spectroscopic data. Students, the answer is here. Ionization energy analysis, last week we discussed. Spectrum analysis. So C and D, question number 11, irradiation, those things are wrong. Cathode ray experiment is not showing the energy level. Spectrum analysis and the ionization energy analysis, C and D. If C and D correct, what is the answer? Question number 11. Third one, very easy. Okay. Right. Now, question number 12 is very important. Now look at this one, okay? Students, I told you in the A-level exam paper, question number 31 to 40 should be done in that way, ABCD statements. In our A-level exam paper, question number 41 to 50, it's like this. So they are giving a table. In that table, we have 10 statements in the left side, like this. First statement, and then they have given second statement. Likewise, they have given 20 statements, right? 10 statements here and another 10 statements here. You take the past paper book and see, will you, right? Likewise, they will give statements. Now, here we have one statement, and oppositely we have another one, like this, right? 41, 42, 43, likewise, they have given two statements in a row. Now, what is the way that now this question number 12 is like that only? See, first statement and the second statement. Then how we can go for the options like 1, 2, 3, 4? Now, this is very interesting, okay? See, will you? First of all, you have to check whether now if you want to choose answer as number 1, the first statement is correct, and second statement clearly explains the first statement, then we have to choose answer as number 1. Okay, that means the second statement should be the reason for the first statement. Now just imagine they have given something happen here, so the reason is given here, second statement is explaining the first one. Then we have to choose answer as number 1. Option number 2, first statement is correct, and second statement is also correct. Second statement is correct and clearly explain the first statement. First statement is correct, second statement is correct, and it doesn't clearly explain the first statement, right? Not explaining first one. Okay, that means no connection. Then the answer is, then third one is first statement is true, second statement is false. Then you have to choose answer as number 3. Fourth one, first statement is false, second statement is true. Then the answer is number 4. Both the statements are false. Then the answer is number 5. Now you may have a question like this. Sir, are you sure? Are you talking about the chemistry paper really? Exactly. Isn't it? Why this much of things? Huh? This is such a pain. When we have 5 options, we can easily go for the answer. They have given these kind of 10 statements. Question number 41 to 50, last 10 MCQs. Right? They have given these kind of statements. They have given first statement is correct. Second statement is also correct. Second statement is clearly explaining the first statement. Then the answer is number 1. Second option, first statement is correct. Second statement is also correct, but second statement is not clearly explaining the first one. Then the answer is number 3. First statement is correct, second statement is wrong, then the answer is number 3. First statement is wrong, second one is correct, answer number 4. If both the statements are correct, if both the statements are wrong, answer is number 5. Can you understand? Students, this is the way that how question number 41 to 50 made in the exam paper. Right? This is the way that they have given. Yeah, they are giving the instructions, right? They are giving the instructions before these questions. They are giving these instructions will be given as I have given you in the past paper question tutorial first page. They will give you these instructions. Follow these instructions and go for the answers. Now in this paper, question number 12 is like that. Now they have given 2 statements. Let's see. The Lyman series is caused by radiation emitted when electrons in hydrogen atoms move to higher energy level and fall back to the low energy levels, right? Lyman series is caused by radiation emitted when electrons in hydrogen atoms move to high energy levels, and fall back to lower energy levels. Uh, this statement is perfect if they have given that low energy level is n equal 1, but we can't say this is wrong because that's why Lyman series is obtained when the electrons are moving from high energy level to low energy levels, right? That statement is correct. The frequency difference between the first two lines of Lyman series of hydrogen emission spectrum is greater than the frequency difference between the first two lines of the Balmer series, right? Let me consider the Lyman and Balmer series again, right? Do you want to note down this one? Quickly note down. Right, okay. Now let's move to the question number 12 again. Students, question number 12, the first statement is okay. No issue with the first statement. Now let's consider the second statement. Let me draw the line series again. Let me draw Lyman and Balmer only. Look at this one. The frequency differences between the first two lines of the Lyman series. First two lines, this one and this one, in the Lyman series. Frequency difference, no. We know that these two lines are, these two energy levels are representing. This line is representing the energy level gap between these two. And this line is representing the energy level gap between these two. So therefore, these two line gaps are representing the energy gap between these two. Let me consider this one as delta EL. Okay, delta EL, first line and the second one, is greater than the frequency difference between the first two lines of the Balmer series. So this is the first two lines. Then we can consider delta EB. I told you that, students, energy is directly proportional to the frequency. As you can see here, delta EL, this is greater than delta EB. Delta means actually a difference, okay? Delta means a difference. Since frequency is directly proportional to the energy, I can say that they have given the frequency difference between the first two lines of the Lyman series of the hydrogen emission spectrum is greater than the frequency difference between the first two lines of the Balmer series. Yeah, that's correct. Instead of energy, I can take frequency. Delta nu L is greater than delta nu B. Understood? Delta nu L is greater than delta nu B, because energy is directly proportional to the frequency. Then first statement is correct. Second statement is also correct. Students, now second statement is it explaining the first statement? Tell me. Now we know that we can go for two options, number one and number two. What is number one? First statement is correct. Second statement is also correct. Second statement is clearly explaining the first one. Then option is number one. First statement is correct. Second statement is correct. Second statement is not clearly explaining the first one. Then what is the option here, as you think? Lyman Balmer, is that the reason for electrons are going for high energy levels and coming back to the low energy levels? No, no connection. So therefore, question number 12, answer should be second one. Question number 12, answer should be second one. Raise your hand, those who choose the answer as number 2. Good. Students, these things are not difficult, okay? You have to understand all these are all the theories that we learn, but the questions are a little bit different, applications are different, but it's not that much of a big deal. You have to understand it. Now let's move to the question number 13. Which of the following statements about electromagnetic radiations of wavelength 420 nanometers is true? which of the following statements about the electromagnetic radiations 420 nanometers is true? It has more energy than electromagnetic radiations with the wavelength 220. Students, you know that energy directly proportional to the frequency, energy inversely proportional to the wavelength. When the wavelength decreases, energy is increasing. So let's consider lambda 1. The wavelength that they have given is 420 nanometers. Lambda 2, 220 nanometers. Then tell me which energy is greater, E1 or E2? Which energy is greater, E1 or E2? Lambda is inversely proportional to the energy. E2, right? Lower the wavelength, higher the energy. So therefore, this one has the highest energy. Then is the first statement. It has more energy than electromagnetic radiation with the wavelength 220 nanometers. Is that correct? Wrong. Simple A statement is wrong. In question number 13, simple A statement is wrong. Simple B, in a vacuum, it has higher velocity than radiation of wavelength of 220 nanometers. I clearly explained you that in a vacuum, electromagnetic radiations has the velocity of light 3 into 10 to the power 8 meters per second, same velocity. That statement is also wrong. C, the energy of a photon is lower than the energy of a photon of radiation with the wavelength of 220 nanometers. The energy of a photon is lower than the energy of a photon of radiation with the wavelength 220 nanometers. It's the same thing, right? E1 means actually we are calculating the energy of a photon, right? Using hc over lambda. Energy of a photon is lower than the energy of a photon of radiation with wavelength 220 nanometers. Yes, lower the wavelength, higher the energy of a photon. So therefore, that statement is correct. Simple C statement is correct. Simple D, its energy per mole of photons is 4.7 10 to the power minus 19 joules. Right. Per mole. Let's calculate that one for per mole. Do the calculation. 420 nanometers. In order to calculate the energy per mole, its energy per mole of photons is 4.7 10 to the power minus 9. Students, it should not be this value. Actually, by looking at the 10 to the power value, you should be able to answer that one. Right? The per mole energy cannot be this value. Let's see. Hc capital over lambda. 6.626 10 to the power minus 34 joule seconds. Velocity of light 3 into 10 to the power 8 meters per second. Avogadro is 6.022 10 to the power 23 per mole. And the lambda wavelength should be 4.2 10 to the power minus 7 meters. Meters will cancel off, second per second will cancel off. I told you that 6.626, 6.022 multiplication is equal to 39.9. $31, 38 joules per mole. So when you simplify this one, 39.9 is 60101 point. 14.0, 1461, take the difference, 9, 4 here, 5, 4, in this way. 1.4549. So 4549 antilog. 28.5. Yeah, 28.5. So they have been given in joules per mole. This is the answer. So therefore D statement wrong. Maybe if you calculate this one for energy of a photon, then what could be the answer? Then we can say that 1.4, 6.626 divided by 1.4. Then we have 4.7. If we calculate the energy for photon, then we have the answer like 4.7 10 to the power minus 19. But this is actually per mole. So therefore, this should be the answer. If you tell this one in kilojoules, we can say that 285 kilojoules per mole. Students, A, B, D, all of them are wrong. Only C is correct. What is the option that you have to choose? Sorry. What is the option that we have to use? 5. Number 5. Question number 13. Answer should be number 5. Do the calculation quickly. We have only 2 more questions. Right, okay? Question number 14. Oxygen 17 and Y are released when nitrogen 14 atom is bombarded with X. X and Y could be in orderly. Okay, right. Let's see how we can do this calculation. Are we done with this calculation? I'm going to erase this one. Question number 14. O17 is reacted with nitrogen is bombarded with X. Then it is producing O17 and Y. First, we know that nitrogen is 740, oxygen is 817. Then what could be X and Y? Let's see. For the X and Y, they have given electron and hydrogen. The first option, A -10 and hydrogen. 1 1. Can it be? If I put electron here, then 7 minus 1, it becomes 6. Already 8 is there. First one is not correct. Second one, alpha particle and hydrogen. Alpha 2 4, hydrogen 1 1. Alpha particles 2 4. That means let me put alpha 2 4, hydrogen 1 1. Is it balancing properly? 9 9 14 4 18. Yeah, that's correct. Ne? Second one is correct. Second one is okay, right? 7 2 9 8 1 9. Here 14 4 18. 17 plus 1 is 18. But anyhow, let's go for the other things also. Third one, beta particle. Beta particle means beta minus 1 0 electron. Helium nucleus plus helium nucleus means alpha particle. Helium 2 4. Right? So therefore, what do you think? Beta minus 1 0. Helium nucleus. We don't have to worry about this one. Helium nucleus means alpha particle. So therefore, let's put 2 4. No, right? 7 minus 1 is 6. So here we have 10. Third one is not possible. What about the fourth one? Alpha particle. Helium nucleus. Helium nucleus means alpha particle. Helium nucleus means alpha particle. So can be alpha particle in both sides? No, it's not possible. Last one, neutron 0 1, beta particle, beta minus 1 0. So let me put here in 0 1, beta minus 1 0. So it's not balancing. The masses are not balancing, right? 15 17. So the correct option should be X should be alpha particle and Y should be hydrogen. Then perfectly balancing. 7 plus 2 9, 8 plus 1 9, 17 plus 1 is 18, 14 plus 4 is 18. So therefore, question number 14, answer should be second one. Raise your hand those who got the answer as the second one. Okay, good. Right, okay, last question in the paper. Last question in the paper. In 1999, a Russian scientist has made an element capital A, in which the atomic number is 114. This had been done by the bombarding nuclear reaction with element X, which is in the group 2 of periodic table on plutonium. The reaction is given below. A plutonium 94-244 is reacting with that X element, which is in the group number 2, is producing capital A 114. I think that should be the new element, and mass is 289. And 3 neutrons are released. N is a neutron. X could be. Plutonium 94 244 plus X producing A 114 289 plus 3 neutrons 0 1 into 3. Okay. So let me consider A and B. A and B. So therefore 94 plus A, here 114. Then A should be, what is it? 20. Then 244 plus B equal to 289 plus 91 plus B equal 290 minus 244. (46). Students, what is the 20th element in the periodic table? First of all, tell me what are the group number 2 elements? Group number 2 elements in the periodic table are known as alkaline earth metals. These are known as alkaline earth metals. When we are discussing about the periodic table, I'll teach you this one. Beryllium, magnesium, calcium, strontium, barium, radium. Radium is radioactive. So these are actually considered as what? Group number 2. Beryllium is 4th element. Magnesium is 12. Calcium is 20. Strontium is 38. Barium is 56. So this is actually calcium. So this is the isotope of calcium 2046. Plutonium is bombarded with calcium. Then they have produced this kind of a new element that Russian scientist has found 114th element in the periodic table. So what is that element? Flerovium kind of element like that. Fl. Go to the periodic table and see, will you? Fl. Flavorium. Okay, this element. So here answer should be calcium 2046. Question number 15 answers third one. Right. Okay, the memory booster 4 paper is actually really good paper, right? I also didn't realize this much of good questions are there, but that's a good paper. Right. Okay, now if you have any doubts, you can ask me anything. And first of all, can I know your marks, students? Anyone got 15 out of 15? Anyone here got 15 out of 15? No. 14 out of 15? Oh, wait. Please raise your hand again. I want to see. Who are they? Vinodi, Varda, and Rishma, Anjali. Okay. So 14. Good. Very good. Now 14 is actually a really good mark for that paper. 13. Raise your hand those who got 13. Takira, Sehara, Ahansa, Asma, Ayman. Okay. 13 is also good mark. Okay, good. 12. Raise your hand those who got 12 out of 15. No one. Raise your hand those who got 12. 11. Raise your hand those who got 11 marks out of 15. 10. Aushini. Okay, good. Not bad, not bad. Okay, right. Right, okay. Students, now these kind of questions will be discussed continuously. Now in the theory classes, we completed hydrogen emission spectrum, and last week we completed the ionization energy analysis, and we completed the electron configuration. Basic theories also we completed. Next week in the online class, we are starting writing electron configuration, and in the physical classes also we are starting writing electron configuration. Right now, what are the doubts you have in these questions? Right now, remember you have to do a self review, students. Right, not only this discussion. You have to find out a lot of papers, do the questions continuously, and try to improve your marks. Okay. Students, now I'm not going to discuss memory booster number 5. I thought of discussing that paper, but I don't have time. Now I'm going for another physical class at 4. So 4 p.m. So therefore, half an hour is not enough to discuss memory booster number 5. So therefore, we can discuss that one in the next week class. But tell me before that, do you have any doubts in the memory booster paper number 4? Again, any doubts? If you have any doubts, you can ask me. Raise your hand those who understood the things that we discussed today. All clear? Ada කරපුවා තේරෙනවද ඔයගලන්ට? Shape the වැඩේ. In the chemistry paper, there are no minus marks. In the chemistry paper, there are no minus marks. Okay. Yes, I discussed some questions in the exercise also, but I couldn't complete everything. We can discuss these questions later. Zainab, there is a recording. I'll send you that recording also. Taqib, what is the doubt in the first question? Which part you didn't understand in the first question? That is related to the de Broglie's equation. So can you remember the de Broglie's equation? Lambda equal now oxygen and helium is there. Right, okay. Now let's apply the de Broglie's equation for both the oxygen and hydrogen. Let me consider lambda is same, H is also same. So let's take the relative molecular mass of oxygen is atomic mass is 16. So there are 2 oxygens, so therefore 32. Let me consider velocity is v1. Okay, and the same thing for the helium. Lambda h, helium mass is 4. Let's consider that velocity is v2. Then let's take this is number 1 and number 2. Number 1 and number 2 both are same because lambda, no, right? H over 32 into v1 equals to h over 4 into v2. H cancel off. Here 4 and here 8. Then we have to take the ratio between v1 and v2. No? v1 over v2 is equal to 1 over 8. That means v1 equal v2 equal to 0.125. That's all. Can you understand? It's very simple. Now, okay, Taqib. Okay, Sahara. Okay. Shakya, do you have any doubts? Yeah, if they have given helium first, then it would be 8. But they have given oxygen at first. Then we have to consider the proper order is also there. Okay. Order is also important. Right, okay. Then students, let's meet on the next theory class. Please do these papers again, and let's discuss the paper number 5 also. I will upload paper number 6 also in the next class. Study the theories. Probably next month you will have an exam also. Get ready for that one. Right, then let's meet on the theory class. Until then, bye bye, have fun. Good evening for all of you.